Okay, 6.1, ratios and proportions. They're somewhat intimidating because they're in fractions, but make sure that you get it right in this unit. It will make your life a lot easier in Algebra 2 and Pre-Calc in the near future. Otherwise, you're going to have trouble on the basic stuff when you are trying to handle the more advanced stuff, okay? So when we talk about a ratio, let's say when you're in a competition, a sports event, that the Princeton High School, the Tigers, are winning, and their score on the basketball court says 32. And the other team, the guest team, is 28. When we see the scoreboard looking like 32 to 28, that's a ratio. And when we write it in mathematic terms, we convert it into a fraction. So in other words, in mathematics, ratio is just a fraction. I should use a different color right here. It's just a fraction. And same thing with proportions. Proportions are fractions as well. And proportions is just that it's an equation with two ratios, like A over B equals C over D. And we call A and D the extremes because they're on the outer end, the B and C the means because they're in the middle, okay? And later on we're going to cover something called the geometric mean. In Algebra 2, you're going to learn more about the geometric mean as well. So let's move on. Here we have an example. It says, it asks us to simplify the ratios. Let's start with the first one. 76 centimeters to 8 centimeters. So first of all, we have to write it into a fraction form. Make sure in this case the units are exactly the same, so it's less critical. But when you have different units, we will see later examples. It's really important when you convert them into fractions, carry the units with you. And this way, because it's a division, you can see the first thing that looks exactly the same is the units. So I can cancel the unit. And then I just simplify it. There is obviously a 2 in there. So if I divide it by 2, I would end up having 38 on top and 4 at the bottom. And the CM is gone. And I have another 2 in there, so the bottom will be 2 and the top will be 19. So that's for the first problem. 19 over 2 is the simplest form for 76 cm to 8 cm. Okay, now second problem. Here, notice that it's 4 feet over 24 inches. I cannot just divide these two right here. See these units? Because they're entirely different. So I have to first convert them into exactly the same units first. So I think 1 foot has 3 inches. Is that right? No, I'm sorry. 1 foot has 12 inches in there, I think. So I didn't grow up with the English system. So if I do 12, I can convert that into inches, and the bottom, I'm not doing anything different, right? And now notice that I just converted the unit from feet to inches so that they're consistent, and now I can cancel these two. And so I should have 4 times 12 over 24. Notice that I can cancel, actually, let me cancel 12. That way I have 4 over 2. And so my final answer is 2 over 1, which is just 2. Okay? So again, the important thing here is to make sure you pay attention to unit. When there are units attached to the numbers, always carry the units with you, and hopefully you'll get to cancel it like we did in the example above. Here's a real life example. You're painting barn doors. You know that the perimeter of the doors is 64 feet, and the ratio of the length is of the length to the height is 3 to 5. Find the area of the doors. So if you, let's see if I can draw this. I'm terrible with, okay, drawing. Here's a barn. Even though you're painting more than one doors, but the concept is the same, right? So if I have a really large door, and what do barn doors look like? They usually have some paintings on the outside with, it looks more like a barn now. So, okay, notice that it says that the perimeter of the doors is 60 feet. So in other words, this part, that's the perimeter of the door. And so I know if I have to, so if I say, if this is 3x, that's the length is 3x here, this has to be 3x here. If this is 5x, and this would be 5x, right? Because I don't know what, that's a 5x, because I don't know what exactly it is yet. So, and this way I know that if you calculate the ratio of length over height, length is 3x over 5x, and you end up having 3 to 5. So I know so far I'm good. Okay, I also know that if I add the length and add the two width together, I should have my parameter. And since my parameter is 64 and my length in this case is 3x and my height is 5x, so if I do this correctly, this gives me 6x, that gives me 10x. So on the left I should have 16x equals 64. And if you do your division, you should end up having x equals 4. So if x equals 4, obviously 3x is 12, and 5x, which is your height, is 20. Okay, and that gives you, and here we're talking about feet, because notice I should have mentioned this on top. The the unit for the measurement is feet. It's not inches, it's not miles, it's not any other measures, but it's feet. And if you need to find the areas, you've got the information you need to find the area. Is just 12 feet times 20 feet. That should give you 220 square feet. That's the whole area within the red lines. I hope this is helpful. There is another way of solving this. Let's see, how do we, so let's say if we know, here's one equation right here, right? So if we have 2L plus 2W equals 64. We also, from this information, we also know that its length over height equals 3 over 5. Here's a system of equations where you have two variables and two equations, two unique equations, so you can definitely solve for L and the W, and you should come up with the same conclusions right here, 12 and 20, and then from there you can calculate your areas. So I challenge that all of you use this second method as well and try to find the area of the doors, okay? Here's another example. The measures of the angles in triangle BCD are in the extended ratio of 2 to 3 to 4. Find the measures of the angles. Okay, so let's draw a triangle first. So if I have B, C, D, okay. And it says that it's the angle measures that's the ratio, and they call it extended ratio because now it has a third number. So it's saying that in other words, it's also the proportions, right? So this is 2 parts, this is 3 parts, and this is 4 parts. And since we don't know the specific angle measures, I'm going to use x. It's 2x, 3x, and 4x. So notice that if I write them into ratios of b to c, it would be 2 to 3. And in my triangle, it's 2x to 3x. And if you cancel the x out, it does equal 2 to 3. So, and using the same method, you can also do 3x to 4x, which gives you another different way of writing it, is this, and you cancel the x, and you have 3 over 4, which is 3 to 4. So this is just verifying the extended ratio is correctly represented by my triangle on the right. So now that we got the information that we know that angle B is 2x, the measurement for angle C is 3x, and that for angle 4 is 4x. If I add them together, I should have 180 degrees, right? So if you do your math correctly, you end up having x equals 20. Okay. Notice, don't stop there. A lot of times that students just stop there. What they're asking is what? The angle measures for each of the angles. So plug the x back in. So you should have angle B is 2x, so that's 40. Angle C measurement is 3x, so you should have 60. And angle D, you should have 80 degrees. And now verified, if you add the 3 angles together, you have 180 degrees. So most likely that you did it right. And then take their proportion, look at their proportion. It is 2 to 3 to 4. Okay?
In this example, we can see that we're asked to solve for x. So there are several ways of doing it. I'm going to use blue ink to demonstrate one way. Traditionally, in Algebra 1, you probably have learned all I need to do is to multiply 16 on both sides. In other words, I do inverse operation. 16 is 16 over 1, so that gets canceled. I end up having x equals 16 times 3 over 4. And if I further simplify that, I should have x equals 12. That's one way of doing it. In this unit, we're also introducing, a concept called cross products property. And what does cross product property say? What does cross products property say is that if I have a proportion where A and D are the extremes and C and B are the medians, the product of the extremes, meaning A times D, should equal the product of the means, which means C times D in my example. And of course, B and D being in the denominator, they cannot equal to 0 in order for this property to exist. So if I use this cross products property on this example, and this is what I would do. My original proportion is 3 over 4 equals 16 over, x over 16. All I need to do is cross multiply. So I multiply the extremes, which is 3 times 16, and then I multiply the medians, which is x times 4. And then I use inverse operation. I divide it by 4. I get to the same place that my x should equal 12. Okay? This just shows you that math concepts really, that's what makes math easier, is that once you understand the reasons behind inverse operation, you would understand why cross product properties would make sense. And even if you didn't know the name of it, you can use that tool to help you to operate on different math problems. So let's use the same cross product property to solve question B in example 4. if I cross multiply, and again, I want you to pay special attention that you can only cross multiply when you have nothing but a fraction left on each side of the equation. In other words, you can only do that when you have a proportion. It says 3 times x should equal 2 times x plus 1, right? And if you do your distributive property correctly, you should have 2x plus 2 on the right-hand side. And with some simplification, you should arrive at the conclusion x equals 2. Finally, here is a real-world problem. Let's see. You want to find the total number of rows of boards that make up 24 lanes at a bowling alley. So you've got a bowling alley with 24 lanes, and you want to see how many boards there are. You know there are 117 rows in 3 lanes. Find the total number of rows of boards that make up the 24 lanes. So notice that there are lots of numbers and lots of information. And it would be helpful if you organize it a little bit. So let's see. I know that in total I have to find 24 lanes and the number of rows of boards, right? But what I do know is in 3 lanes, I have 117. So, and this way I know that this is a proportion problem. So what this is saying is that if I can do 117 divided by 3, I should be able to find one lane, how many rows do I have? And because I want to find the total number of rows, and I set that as x, and I have total number of lanes is 24. So if my total number of rows x divided by 24, I should arrive at the same answer. And therefore, there's my proportion. And then if I use my cross product property, this one you should be able to use your calculator to make your life a lot easier. And you should come up with the answer of 936. That's the final rows of boards that you have to make up 24 lanes. Okay? And here is another interesting concept. It says the geometric mean of 2 positive numbers, a and b, is the positive number x that satisfies a over x equals x over b. In other words, your median is the same, just one number. And so x squared, if you use cross product property, x squared should equal a times b. Therefore, x is only the positive number of a times b. Okay? I actually recommend that you just remember this part. X equals, this part. X equals square root of a times b. That's the geometric mean. That's fairly easy to understand and very useful in our calculations. So here's a very simple example. And it's asking us to find the geometric mean of 2 numbers. Like I said, the geometric mean x should equals the product of the 2 numbers, and then you take a square root of it. And obviously, 4 times 4 gives me 16, so that's 4 squared. And then in 48, what do I have? If I have to find factors of it with perfect squares, so there's a 4 times, that's 4 times 12, and then another 4 times 3. So in other words, I have another 4 squared, which is 16 times 3 gives me 46. So then this 2 4s comes out. 4 times 4 comes out of the square roots because the square gets canceled by the root. And your final answer of x should be 16 root 3. So that's how we use geometric mean. This is more of a tool. You don't need to memorize it. It's more of a tool for you to learn higher level math in the near future. Okay, thank you guys. Bye-bye now.